All right, strap in, everyone, because today we are diving deep into a cosmic construction zone of sorts.
Oh, I like that.
Yeah.
A cosmic construction zone.
We're calling it the Spiderweb Protocluster.
Okay.
So picture this, right? A massive city of galaxies all under construction.
Wow.
Stars bursting into existence like cosmic fireworks.
Right.
And get this, all of this is happening over 10 billion light years away.
That's pretty incredible.
We have got 2 new research papers,
Okay.
hot off the presses from the Astrophysical Journal.
All right.
And these are based on some observations from the James Webb Space Telescope.
Oh, nice.
And let me tell you,
Yeah.
some mind-blowing findings coming out of this.
It is, it really is like a fascinating glimpse into the early universe.
It is.
It's incredible,
Yeah.
having that,
Yeah.
imagine a time machine,
Yeah.
that can peer back over 10 billion years.
Right.
That's what the James Webb Space Telescope is allowing us to do.
Well, yeah.
With these observations of the Spiderweb Protocluster.
So, I mean, I think for some of us, I definitely don't spend much time in cosmic construction zones.
Sure.
So what exactly is a protocluster?
Well, think of it as a blueprint for a galaxy cluster.
Okay.
Those
Yeah.
massive galleries of galaxies that we see throughout the universe.
Right.
A protocluster is just a region
Okay.
where, hundreds, thousands of galaxies are drawn together by gravity.
All right.
And they're just slowly forming the building blocks of those larger structures.
So it's like we're watching a city being built from the ground up, but on a cosmic scale.
Exactly.
I like that.
Yeah.
And that is where the James Webb Space Telescope comes in, right?
Yeah.
I mean, it's not just taking pretty pictures.
Yeah.
It's giving us a whole new way of seeing these early galaxies.
Exactly. One of the most incredible things about the James Webb Space Telescope
Yeah.
is its ability to see infrared light.
Right.
Now, you have to understand that space is filled with dust and gas,
Yeah.
which can block visible light, kind of like trying to see through a dense fog.
Right.
But infrared light,
Yeah.
it's like having night vision goggles.
Okay.
Webb can cut through that cosmic haze and reveal galaxies that would otherwise be hidden from our view.
Oh, that's amazing.
Yeah.
So it's like Webb is giving us like X-ray vision to see the universe's skeleton.
Yeah, that's a great way to put it.
Yeah. So what is it revealing in the Spiderweb Protocluster?
Well, get this.
Okay.
The observations.
Mm-hmm.
Uncovered way more galaxies within the protocluster than anyone expected.
Oh, wow.
It's like this cosmic party is even more crowded than we thought.
Really?
But here's where it gets even more interesting.
Okay.
The galaxies they already knew about.
Yeah.
Not as dusty as predicted.
Wait, hold on.
Yeah.
That's a curveball.
Yeah.
Because didn't astronomers think that like all those galaxy interactions and mergers
Mm-hmm.
in these dense environments should kick up a ton of dust and gas, which fuels star formation?
That's been the prevailing theory, yes. But these observations
Yeah.
are challenging that assumption.
Wow.
Yeah, it's almost as if
Yeah.
there's another force at play.
Right.
Something beyond just collisions and mergers that's driving the star-forming frenzy in this protocluster.
So what are the scientists proposing as like the alternative explanation?
Well, one of the papers
Yeah.
suggests that gas might be flowing in
Okay.
from the larger cosmic web,
Oh, wow.
like a vast network of pipelines delivering fuel to these growing galaxies.
So instead of just like smash and grab tactics,
Right.
these galaxies are tapping into a broader,
Mhm.
more organized system of gas distribution.
That's the idea.
Wow.
And it has big implications for how we understand
Yep.
the formation and evolution of galaxy clusters.
Right.
If interactions aren't the primary driver,
Yeah.
then this large-scale flow of gas
Right.
could be the key to building these massive cosmic structures.
So these findings aren't just like tweaking our understanding a bit. It's like they're really shaking things up.
Absolutely.
This could rewrite our textbooks
Yeah,
on galaxy formation.
totally. And remember, these are just initial observations.
Yeah.
Imagine what we'll learn as Webb dedicates more time to studying this protocluster.
That's what I find so exciting about this. It's
Yeah.
like we're just scratching the surface
It is.
of what Webb can reveal about the early universe.
It's just the beginning.
And it's already turning our assumptions upside down.
I know. It's exciting, isn't it?
Yeah.
It's really cool.
Yeah, it is really cool.
It's a great time to be in the field.
It really is.
Yeah. Yeah, it's a really revolutionary time in astronomy.
It is.
These findings, I think, have opened up a whole new set of questions about how galaxies
Right.
form and evolve in these dense environments.
Yeah. And speaking of questions,
Yeah.
one thing that really piqued my curiosity in these papers was the discussion of different types of galaxies
Yeah.
within the protocluster. They mentioned something about ordinary galaxies
Yeah.
being less dusty than anticipated.
Right.
So what's the deal with that?
Well, you see, astronomers, they often classify galaxies
Okay.
based on their star formation rate.
Okay.
So some galaxies, like our own Milky Way,
Yeah.
are considered ordinary
Okay.
in the sense that,
Yeah.
they're steadily forming new stars,
Okay.
but they're not going through a particularly explosive phase.
So they're like the steady eddies of the galaxy world.
Exactly.
Yeah.
Not too wild, but not completely quiet either.
Gotcha.
So the traditional thinking was that in these chaotic, crowded protocluster environments,
Right.
even these ordinary galaxies
Yeah.
would be spurred into like a star formation frenzy
Right.
due to all the interactions and mergers.
Right. Right.
But what Webb's observations are showing
Yeah.
is that these ordinary galaxies aren't as dusty as predicted,
Right.
which means
Yeah.
they're not forming stars as rapidly as we thought they would be.
So that's even more evidence that there's something else at play here.
Right.
Something beyond the simple model of galaxy interactions driving everything.
Exactly.
It seems like those ordinary galaxies are playing by a different set of rules.
And it suggests that different types of galaxies within the protocluster
Right.
might be responding to different influences.
Oh, okay.
Perhaps the ordinary galaxies are more sensitive to this large-scale gas flow,
Okay.
while the more active starburst galaxies
Right.
are still primarily driven by interactions and mergers.
It sounds like we're witnessing a complex interplay of forces, like
Mhm.
a cosmic dance with different types of galaxies moving to their own rhythm.
Yeah, that's a good analogy.
And it makes me wonder, with all this gas flowing in
Yeah.
and fueling star formation, what does this tell us about the
Mhm.
bigger picture
Yeah.
of how galaxy clusters evolve?
Well, that's a great question,
Yeah?
and the answer might surprise you.
Okay.
This actually points to a more organized
Okay.
and structured early universe
Right.
than we previously imagined.
Wow.
So instead of a chaotic mess
Right.
of galaxies just colliding randomly, it seems there was a more coordinated flow of matter,
Okay.
laying the foundation for these large-scale structures.
So it's like watching the universe play a giant game of connect the dots.
Yeah, I like that. That's good.
With galaxies.
Yeah.
Yeah, and we're seeing the lines being drawn right in front of our eyes.
Yeah.
But what I find truly remarkable is that we're able to make these observations from our little corner of the universe, you know?
I know. It's incredible, isn't it?
Yeah, it makes you appreciate the ingenuity of the scientists,
Oh, I've seen
like engineers who
Yeah.
built this incredible instrument,
phenomenal.
the James Webb Space Telescope.
Yeah, it's a real testament
Yeah.
to human curiosity and our drive to understand our place in the cosmos.
Yeah, it is.
And these findings in the Spiderweb Protocluster are just the tip of the iceberg.
It is.
With more time and deeper studies using Webb,
Yeah.
we're poised to unravel
Right.
even more secrets
Yeah.
about the early universe.
You know, while reading these papers, I noticed the researchers are already planning follow-up observations
Oh, cool.
with Webb focusing on specific galaxies
Okay.
within the protocluster.
Nice.
What can they learn by zeroing in on individual galaxies like that?
Well, they'll be using Webb's special tools
Okay.
called spectrometers,
Okay.
which are like cosmic fingerprint scanners.
Okay.
They can break down the light from a galaxy into its different wavelengths,
Okay.
like a rainbow.
Right.
And by analyzing these wavelengths,
Yeah.
astronomers can determine a galaxy's chemical composition,
Wow.
temperature, velocity,
Okay.
and even the presence of specific elements.
So it's like getting a detailed profile of each galaxy,
Yeah,
revealing its unique history and characteristics.
exactly. You got it.
And by comparing these fingerprints, astronomers can start to piece together
Yeah.
how the galaxies in the protocluster are related to each other, how they're interacting,
Yeah.
and how they're contributing to the overall growth
Exactly.
of the cluster.
That's exactly right.
It's like having a backstage pass to the most epic show in the universe.
Yeah, it is. It is.
With these follow-up observations, we're going to gain an even deeper understanding of the Spiderweb Protocluster and its place in the grand story of cosmic evolution.
I agree.
It's mind-boggling to think that just a few decades ago, we could only dream of having this kind of insight
I know.
into the early universe.
It's amazing.
And now, thanks to Webb, we're rewriting the story of galaxy formation in real time.
It's true. It's a really exciting time to be an astronomer.
It is.
Every new observation with Webb seems to bring us closer
Right.
to understanding the fundamental forces
Yeah.
that shape the universe as we know it.
And, beyond the scientific discoveries,
Yeah.
these images from Webb are just breathtakingly beautiful.
They are stunning.
It's a constant reminder of the awe-inspiring power
Yeah.
and beauty of the universe we live in.
Absolutely. Couldn't agree more.
Yeah, it really is humbling when you think about it.
It is.
Here we are on this tiny planet,
Right.
able to unravel the mysteries of galaxies billions of years old.
Yeah.
It really makes you appreciate the power of human ingenuity,
Absolutely.
collaboration.
Yeah, the James Webb Space Telescope is a true testament to what we can achieve when we work together.
Totally.
Scientists, engineers, technicians
Yeah.
from all over the world
Yeah,
have poured their passion and expertise into this incredible instrument.
right.
And the results are they're awe-inspiring.
They're incredible. I mean, it's like we've been handed a key to unlock the secrets of the universe.
Yeah.
And the Spiderweb Protocluster is just one of many fascinating places Webb is exploring. But before we get too carried away
Okay.
with all the possibilities,
Yeah.
let's take a moment to recap what we've learned
All right.
about this particular cosmic construction zone.
So, rewind.
Okay.
First, we discovered that the Spiderweb Protocluster
Yeah.
is teeming with way more galaxies than anyone expected,
Right.
all packed together like a bustling city.
Yeah, like a cosmic party.
Exactly.
Yeah.
But here's the kicker, right?
Right.
Those galaxies
Yeah.
aren't as dusty as they should be,
Right.
considering all the hustle and bustle of star formation going on.
Right. And that's what threw a wrench into our old theories about galaxy evolution.
It did.
Instead of just chaos and collisions driving everything,
Mm-hmm.
it seems there's a more organized system at play
Right.
with gas flowing in from the larger cosmic web
Exactly.
to fuel those growing galaxies.
Yeah, like a network of pipelines,
Yeah, I like that analogy.
keeping those galaxies fueled.
Yeah.
And we talked about the idea that different types of galaxies
Yeah.
within the protocluster
Right.
might be responding to different influences.
Yeah.
Perhaps those ordinary galaxies are more sensitive to this large-scale gas flow,
Right.
while the more active starburst galaxies are still getting a boost
Okay.
from those interactions and mergers.
So it's really a complex dance.
And
And we're just beginning to understand the steps.
yeah, we're just getting started.
But I think what really struck me
Yeah.
was the implication that the early universe
Mm.
might have been more structured than we previously thought.
Right.
This picture of a coordinated flow of gas
Yeah.
laying the foundation for these massive galaxy clusters.
Right.
It's totally changing our understanding of how things work on a cosmic scale.
It really is a paradigm shift.
It is.
And it opens up a whole new set of questions.
Right. Like, if galaxy interactions aren't the primary force
Yeah.
shaping these early clusters,
Yeah.
what else is at play?
Right. Like, what else is going on?
Yeah. Could it be dark matter?
Possibly.
That mysterious substance we
Yeah.
can't see, but no, is there,
Right.
could that be influencing this process?
Could it be?
Or could it be something even more exotic?
Yeah.
Something we haven't even imagined yet?
Who knows?
Now that is a cliffhanger.
It is.
It really is a reminder that for all we've learned,
Mm-hmm.
the universe is still full of mysteries.
So many mysteries left to uncover.
And you know me, I love a good cosmic puzzle.
Me too.
And with Webb as our guide,
Yeah.
we're in for some exciting discoveries in the years to come.
Absolutely.
So if you're eager to learn more about the James Webb Space Telescope
Yeah.
and the groundbreaking discoveries it's making,
Mm-hmm.
be sure to check out the ESA's website.
Yeah, good resource.
And you can find the full scientific papers
Yes.
we discussed today
Yeah.
on the Astrophysical Journal website.
That's right.
We'll provide links in the show notes.
Excellent.
Until next time, keep looking up
Yeah, keep looking up.
and keep wondering.
Absolutely. Who knows what we'll find next?
And remember, you don't need a fancy telescope to appreciate the wonders of the universe.
That's right.
Sometimes all it takes is a clear night sky and a curious mind.
That's all you need.